Where do I start the first problem at? Add 5 to both sides. We need to isolate first. So I'd have 2 times the absolute value of 5x minus 3 equals 21. Then what? Divide both sides by 2. Dividing both sides by 2 does not get rid of my absolute value. One of the things that I noticed happen a lot on the last quiz, which I will be passing back today, is that we were dropping the absolute value and just ignoring it from this point forward, which meant we only got one answer, but there's actually how many answers to this absolute value? 2. 1 positive, 1 negative. So 5x minus 3 is equal to negative 21 over 2, or 5x minus 3 is equal to positive 21 over 2. You have to do both of them. If you only find one answer out of 2 answers, you're only going to end up with half the points because you only found half the answers there. I'm going to add 3 to both sides. So 5x is equal to, I believe this is negative 15 over 2, negative 21 over 2 plus 6 over 2. Is that correct? Because I need a common denominator. Okay. And then I divide both sides by 5. Remember, dividing is the same thing as multiplying by the reciprocal. So when I do negative 15 over 2 divided by 5, that's the same thing as multiplying by 1/5. So I get that x is equal to negative 15 over 10, which I can reduce down to negative 3/2. For the other side, I'm going to add 3 to both sides. I get 5x is equal to 27 over 2. Divide both sides by 5, or multiply both sides by 1/5. And I get that x is 27 over 10. Absolute value, 99% of the time, has 2 solutions. The only time it would not have 2 solutions is if you isolate your absolute value and you get a negative over here. Distance can't be negative, so that would be a no solution situation. The only other time that we're not going to have 2 answers is if when you isolate the absolute value, you have a 0 over here. Then there would only be 1 solution, because we can't have a positive 0 and a negative 0. We would just set it equal to 0. Do you guys have any questions for me on number 1? Number 2, what do I do with this? How do I set it up? Anthony. One positive, 1 negative. So I'm going to think about this on a number line as I set it up. So it's telling me that my distance is 8 units away from 0, but I want it to be greater than. Well, I know if I want it to be greater than 8 units from 0, I can go off this way and be more than or greater than 8 units away from 0. What about over here? Would it go this way also? It's going to go the other direction. If I'm going to the left, is that a greater than or a less than? I have a less than here, but a greater than here. If my absolute value is isolated and it is greater than some number, it's going to be less than the negative. 5x minus 3 is less than negative 8. Or 5x minus 3 would be greater than positive 8, because I want my distance to be more than 8 units away from 0. So negative 8 and everything to the left of that, or less than that, would be more than 8 units away from 0. And then we solve each of these, add 3 to both sides. I get 5x is less than negative 5. Divide both sides by 5. X is less than negative 1. Or I add 3 to both sides over here. 5x is greater than 11. Divide both sides by 5. X is greater than 11/5. Again, thinking about this on a number line, I've got -1 here, 11/5 here. This is my solution set. So when I go to write this using my interval notation, it is -infinity up to -1, union 11/5 to infinity. So far, so good? Let's do the last one on the bell work. No absolute values over here on number 3. Where do I start that one at? Subtract 5 from all my sides. Since I have 2 inequalities, I have to do it on either side there. So I have -1 is greater than or equal to 3x is greater than -6. And then what? Divide everybody by 3. So I have -1/3 is greater than or equal to x, which is greater than -2. This would be an incorrect answer, but I see students do it all the time. That is not right.
It should be the other way around.
Why?
Because -2 is less than 1/3.
Yes, -2 is less than 1/3. When we write our interval notation, it is always the smallest or the farthest to the left on a number line, and then we end it with the one that is farthest to the right on the number line. So correct interval notation here would be -2 parentheses -1/3. That would be correct. Because that's what that would look like. All right. Do you guys have any questions for me on the bell work? We have just a few more examples that I wanted to look at with you guys from 2.7, and then you guys will have the remainder of class time to work on your reviews. Looking at this guy right here, I have a rational, and then an inequality, and then another rational. Talk to me about first steps. I want one side to be a 0. So I'm going to subtract one of my rationals to the other side. I'm going to go ahead and subtract 2 over x plus 1 from both sides. So that's going to give me a 0 over there on the right. Thank you, computer. That wasn't loud at all. And it's not even open on my computer, so I don't know why. What do I do from here? Yep, I'm going to need a common denominator. These two denominators don't currently have anything in common. So I multiply this first rational by x plus 1, top and bottom. The second rational by 3x minus 2, top and bottom. So I have 4 times x plus 1 minus 2 times 3x minus 2 all over my common denominator. And that should be less than or equal to 0. I'm going to distribute and combine my like terms up in my numerator. So I have 4x plus 4 minus 6x plus 4 all over my common denominator of 3x minus 2, x plus 1, less than or equal to 0. How does that numerator clean up then? Negative 2x plus 8. I know I can take a GCF out of that. It doesn't help, it doesn't make my problem any easier, and it does not get me closer to my answers, so I'm not going to. All right, so what values make my factors 0? Yep, so we have, you said -4, 2/3, and -1. Beautiful, beautiful.
Which part does -4 go into?
Good question. How do we feel about our zeros?
Just be 4.
Yes. Why is it just 4?
Because that would be 6.
-2, so if you did a positive, if you did a -4, it'd be 8 plus 8.
Yes. So it's a +4, because if I substitute a +4 in the place of x in that numerator, then I would have -8 plus 8. That would give me a 0. Nice catch there. All right, what can x not equal? Yes. 2/3 and -1. That's going to be important. So the only one that's included is this 4 for that or equal to part. I'm going to draw my number line. Which thing should go first on the number line? -1. So I have -1. I have a +2/3. I have a +4. I need all of my factors, -2x plus 8, 3x minus 2, x plus 1, and then I need a row for my result. Give me a test value less than -1. -2. -2 times -2 plus 8. Positive. 3 times -2 minus 2. Negative. -2 plus 1. Negative. For an overall result that would be positive. Yes, sir. Thank you. Test value in between -1 and 2/3. 0. -2 times 0 plus 8. Positive. 3 times 0 minus 2. Negative. 0 plus 1. Positive for an overall result that is negative. In between 2/3 and 4. 1. -2 times 1 plus 8. Positive. 3 times 1 minus 2. Positive. 2 plus 1. Positive. For an overall result that would be positive. Don't forget we are including this 4. That's the only one that it could be or equal to. Test value bigger than 4? 5. -2 times 5 plus 8. Negative. 3 times 5 minus 2. Positive. And 5 plus 1. Positive. Overall result? Negative. Did we want the positives or the negatives? Yep, right down here. Less than 0. I want my negatives. And we have to make sure anything that gets that or equal to gets included there. So I want this interval. I want this interval. Parentheses or brackets for my first interval? Parentheses. -1 to 2/3. It cannot be equal to either of those, because those would make my denominators a 0. Parentheses or brackets for my last interval? Bracket. 4 to infinity. It can be equal to 4. I would love to use brackets on everything, but I can't have it equal to something that would make my denominator a 0. So it has to be parentheses there. You guys okay with this one? All right. This is the last screen. First thing I would do on part A is I would get this guy set not equal to 0, but greater than or equal to 0. So I'm going to make the right hand a 0. What can I do with this now? Factor it. I'm going to go ahead and use a little u substitution. Let u equal x squared. So I would have u squared plus 13u plus 36 is greater than or equal to 0. What's going to multiply to 36 and add to 13? 9 and 4. So I have u plus 9. U plus 4 is greater than or equal to 0. I let u stand in for what? X squared. So this is really x squared plus 9. And x squared plus 4 is greater than or equal to 0. If I take a number and I square it, what type of number will I always end up with? A positive. So if I take a number and I square it and then I add something to it, it's always going to be a positive. So this one over here is positive for all real values of x. What about this one? Same exact thing. It's positive for all real values of x. Is there anything that we could put in here for x that would make this whole polynomial come out to be less than 0? No. So what's my answer then?
No real numbers.
No real numbers? I can't put anything for x and have it be positive? All real numbers. So in interval notation, that would be negative infinity to positive infinity. If I'd had the exact same problem, but my inequality had been the other way around, if this had been a less than problem instead of a greater than, that would be no solutions, no real numbers. Because it's greater than and we can only get positive results, it is all values. What can I do with part B?
Factor by grouping.
Yep, let's factor by grouping here. So I'm going to make my first group and my second group. Out of the first group, I can take out an x squared. That would leave me with x plus 2. What can I take out of the second group?
Negative 4.
Negative 4. That would also leave me with x plus 2 is greater than or equal to 0. So I have x squared minus 4 and x plus 2. Is that fully factored?
No.
No, I have to finish factoring this. How does x squared minus 4 factor?
X plus 2,
X plus 2, x
x minus 2.
minus 2. We already had an x plus 2 here. Where is this greater than or equal to 0? So where are my zeros? Negative 2 and positive 2, right?
Yeah.
I'm going to do my number line. Negative 2, positive 2. The factors that I need all three of those factors. X plus 2 appears on there twice, but I need to include it both times. You can't leave it out. I just know it's going to come out to have the same values when I plug in my test values. Something less than negative 2.
-3.
Negative 3. What's going to happen all the way down?
Negatives.
Negatives all the way down. When I multiply 3 negatives, I get a negative result. Give me something to test in between negative 2 and positive 2. 0. So positive, negative, positive. For what kind of a result? Negative result. Something bigger than 2.
3.
3. What's going to happen all the way down?
Positives.
Positives all the way down for a result that would be positive. Do we need to include anybody?
Yes. 2.
2.
Yeah.
Do I need to include negative 2?
No,
Why not?
because it would be negative. It would still be negative.
Would it make my original polynomial or equal to 0?
No.
If I put a positive 2 in my original polynomial.
You said negative.
Sorry, if I put a negative 2 in my original polynomial, my bad. Negative 2 cubed, that'd be negative 8. Negative 2 squared, that'd be 4 times 2, that'd be positive 8, so that would cancel. That would be a positive 8, that would be a negative 8, that would cancel. Will it make it or equal to 0? Then I have to include this. So what is my solution then?
Early brackets, negative 2, union, bracket 2, comma, 8.
Yes. Any values greater than positive 2, any values bigger than positive 2 make my whole original polynomial greater than 0. Right at positive 2 and right at negative 2, it makes it or equal to. So I have to make sure that those get included in my solution set. All right, last one. First thing I need to do here is subtract x from both sides so that I get a 0 on the right. X cubed minus x is greater than 0. Can I factor anything out? X. So x, that would leave me x squared minus 1. Does anything factor further?
Yeah.
Yep, x squared minus 1 factors to be what?
X minus 1,
X plus 1 is greater than 0. So where are my zeros? 0, 1, and negative 1. Do we need to worry about including anything? Are we going to have any brackets at all?
No,
Why not?
because it's not greater.
Yep, it doesn't have that or equal to with it. If there is no or equal to, I'm never going to have to worry about square brackets. All right. Let's pick out some test values. Something smaller than negative 1. Negative 2. So that's going to make this first one negative.
Negative all the way down.
Negative 2, negative 2 substituted in there, so we have a negative result. In between negative 1 and 0,
Negative 0.5.
negative 0.5. So I get negative, positive, negative,
Which is positive.
which is an overall positive result. Something in between 0 and 1,
0.5.
0.5. Positive, positive, negative for an overall negative result.
2.
2. What happens all the way down?
Yep. Positive.
They're all positives all the way down. Did I want the negative intervals or the positive intervals? Positive intervals. Greater than 0 is positives. No included values because we don't have the or equal to here. So from negative 1 to 0, union 1 to infinity. All right. That is everything. That is absolutely everything in all of Chapter 1 and all of Chapter 2. Your test on Friday covers everything in Chapter 1, that's 1:1 through 1:4, and everything in Chapter 2, that's 2:1 through 2:7. You guys have the remainder of the time to work on your review. I did want to show you quickly, in case you haven't done any investigation on our class Canvas page. If you go to today's class Canvas page, this was true about yesterday's as well, but I didn't have time to point it out, and you scroll all the way to the very bottom. 2.7 homework is due tonight. Here's a PDF copy of the review in case you lose yours or you want to print off another one. All of the answers are here. This is not my work, but this is so you can check to see if you got the right answer. My work will be going up after school today. So after school today, down even lower at the bottom, at the very, very, very bottom, is where the link will be for all of my complete worked out solutions. And it will say solutions, not just answers. It'll say solutions with work. And it'll be a large link.